Today in physics, now to see one topic from the chapter electrostatic potential and capacitor. The topic is to find the or to obtain the equation of electric potential due to dipole at a point, and also show that the potential at its axis and equator. Now the topic is like this way, just we can see here. Derive the formula for the electric potential due to the electric dipole, a point. From it, mention electric potential on the axis and on the equator for the electric dipole. Now, we have to draw the figure here. Suppose you can see here. Suppose this electric dipole at the origin, that is a plus q and minus q o, and suppose point P is here. Point P, the position vector, that is r1 from positive q charge, and from negative q charge, that is a position vector r2, and position vector from O, that is here r. Now dipole, that is here 2a, and now the perpendicular is drawn. The perpendicular is drawn from plus q on this OP, that is here 90. It intersect at M, and perpendicular drawn from O on minus QP, that is here N. Now angle plus QOM is theta. This is theta, and here also angle O minus QN is theta. Let the dipole is placed at the origin O, having distance 2a. The dipole is written by P is equal to 2aq. Now select a point P, and from plus q, the distance is r1 or position vector r1, and from negative q, the position vector r2. Similarly, from O, that is OP, is equal to vector r. Now the potential due to plus q charge, that is V1 is equal to K plus Q upon R1, number 1. Similarly, the potential due to negative q charge, that is V2 is equal to K minus Q upon R2, number 2. Now the total potential, that is total potential, V is equal to V1 plus V2 is equal to kq upon r1 minus kq upon r2. Now taking the common here, so we can get here kq and here 1 upon r1 minus 1 upon r2. This is the first equation. So we can write here first equation, v is equal to kq 1 upon r1 minus 1 upon r2. Now plus qm perpendicular drawn on OP, that is intersect at point M. Therefore triangle plus QOM and angle plus QOM is equal to theta. Therefore cos theta is equal to adjacent upon hypotenuse. So this is 90. So front, that is hypotenuse, this is adjacent. So that is OM upon O plus Q is equal to A upon. Now this distance is R1, this is R. So this perpendicular is drawn. Then this distance OM is equal to R minus R1. So keeping this value here, therefore R minus R1. Therefore R minus R1 is equal to A cos theta. Therefore R1 is equal to R1 this side, so we can write R minus A cos theta. Now simplifying, we to get here. Therefore R1 is equal to, we to take R common, so 1 minus A upon R cos theta. Now squaring both the sides, so we can get here R1 square is equal to R square 1 minus 2A upon R cos theta plus A square upon R square cos square theta. Now you can see here R is greater than A, therefore this term is negligible, very small. So finally we can get here R1 square is equal to R square 1 minus 2A upon R into cos theta. Now taking the square root, so we can get here R1 is equal to R 1 minus 2A upon R cos theta raised to 1/2. Now we can take 1 upon R1 is equal to 1 upon R. We can write 1 minus 2A upon R cos theta raised to minus 1/2. Now writing two terms and using binomial theorem and writing only two terms, and higher term will be neglected. So finally we can get 1 upon R1 is equal to 1 upon R. This will be multiplied here, so 2 will be cancelled, minus minus plus, so 1 plus A upon R cos theta. So this is the second equation. So you can write your second equation here, that is 1 upon R1 is equal to 1 upon R 1 plus A upon 1 upon A upon R into cos theta. This is second equation. Now again we have to we can take this, that is a ON is perpendicular on minus QP and intersect at N, and angle O minus QN is equal to theta, and right angle triangle ON minus Q. Cos theta is equal to adjacent upon hypotenuse, so here minus Qn upon O minus Q. Therefore cos theta is equal to minus Qn means here that is this distance here. So we can write R2 minus R. So this is R2 minus R. So we can get here R2 minus R. So R2 minus R divided by A. Therefore R2 minus R is equal to A cos theta. Therefore R2 is equal to R plus A cos theta. Now again simplifying we to get here, that is R2 is equal to R common we can 1 plus A upon R cos theta. Squaring both the sides we can get R2 square is equal to R square 1 plus 2A upon R cos theta plus A square upon R square cos theta square. Now this term is very small, so that will be neglected because R is greater than A. So writing two terms here, therefore R2 square is equal to R square 1 plus 2A upon R cos theta. Now taking the square root, so R2 is equal to R 1 plus 2A upon R cos theta raised to 1/2. Therefore we can take 1 upon R2 is equal to 1 upon R 1 plus 2A upon R cos theta raised to minus 1/2. Now again using binomial theorem and neglecting higher terms, so we get here 1 upon R2 is equal to 1 upon R1. Now this will multiply here, so plus minus 2 will be cancelled, so we can write here A upon R cos theta. This is equation number 3. Now keeping equation 2 and 3 in equation number 1, now we can get here, that is V is equal to KQ. Now we can write here upon R common, so 1 plus A upon R cos theta, then minus 1 and minus plus A upon R cos theta. 1 will be cancelled, so V is equal to KQ to A upon R into cos theta. Now we can write here K upon R square into 2AQ cos theta. Now we know that P is equal to 2AQ. So we can write here is equal to K P upon R square into cos theta. This is V. Therefore P cos theta is equal to vector P into unit vector R. Keeping this value, so we can V is equal to K P dot R upon R square, or we can write here that is 1 upon 4 pi epsilon 0 vector P dot R upon R square. So this is a required equation. Now we look at here that is at x is the potential. When x is, then theta is equal to 0, then we can use this formula here again. V is equal to K P cos theta upon R square. Now instead of cos theta we can put 0, so we can cos 0, so we can get K P upon R square. Cos 0 means 1, so at x is, that is V is equal to K P upon R square, or 1 upon 4 pi epsilon 0 P upon R square. Now at the equator, V is equal to K P cos theta upon R square. Theta is equal to, that is a 90. So keeping this value here, V is equal to K P cos 90 upon R square is equal to 0. So potential at equator is 0, potential at axis is Kp upon R square. So this is to understand this topic. In this topic, dipole is placed at the origin O having a distance that is 2a of positive and negative charge, that is plus q and minus q, and point P at r1 distance from plus q charge and r2 distance from minus q charge, and from the origin, that is r distance. Now we know that here perpendicular drawn from positive q charge on OP, that is intersect at M, and similarly perpendicular drawn from, that is O, on minus QP, then that is intersect at end. Now here two right angle triangles, and we know that the potential at plus q charge is V is equal to KQ upon R1, and potential at negative charge, that is V2 is equal to minus KQ upon R2. Therefore net potential V is equal to V1 plus V2 is equal to KQ upon R1 minus KQ upon R2. Taking KQ common, so that is in bracket 1 upon R1 minus 1 upon R2, equation number 1. Now we can go from geometry of the figure. Then there are two right angle triangles, so from this we have to get cos theta is equal to adjacent upon hypotenuse. Keeping the we know that here that is cos theta is equal to OM upon QO. Therefore R minus R1 is equal to A cos theta. Therefore R1 is equal to R1 is equal to R minus A cos theta. Now taking the R common from the right hand side, and we can get here R1 is equal to R common, so 1 minus A upon R cos theta, bracket. Now squaring the side, then we have to get here, that is R1 square is equal to R square in bracket 1 plus 2A upon R cos theta plus A square upon R square cos square theta. Now here R is greater than A, therefore A square upon R square cos square theta term is neglecting, and we have to take the reciprocal, and finally we can, using the binomial theorem, and we can get here 1 upon R1 is equal to 1 upon R in bracket 1 plus A upon R cos theta, equation number 2. Similarly for next right angle triangle, we have to get here 1 upon R2 is equal to 1 upon R in bracket 1 minus A upon R cos theta. Now keeping both the value in equation number 1 and simplifying at the last, we have to get here V is equal to KP upon R square into unit vector R. Now we can put K is equal to 1 upon 4 pi epsilon 0. Therefore V is equal to 1 upon 4 pi epsilon 0 vector P dot unit vector R upon R square. Now at the axis the theta is equal to 0. Therefore potential V is equal to 1 upon 4 pi epsilon 0 P upon R square. Now at the equator theta is equal to 90, and cos 90 is equal to 0. Therefore potential at equator will be 0. So this way to understand this topic. Thank you very much.